Hello, welcome back. In this video, we're going to go over an exercise where we're going to decompose a composite function, and we're going to use the formula for taking the derivative of composite functions. And also, we're going to try to find a derivative of the same function with respect to the general power rule. So let's start with the part. So the given function is the cubic root of 6x squared plus 1. So now we should find the inner and outer function. All right, so since this is the cubic root of 6x squared plus 1, so 6x squared plus 1 is the candidate for the inner function for this problem. And the cubic root operation is going to be our outer function. So in other words, we're going to call that to be cubic root of u. So this function is written in terms of u, so that's why we don't have any x expression here. And u is written in terms of x, that's why we have everything written in terms of x here. All right, so let's apply this formula. So y prime is the derivative of the outer function, which is the derivative of f, multiplying the derivative of the inner function, which is u. So if you take the derivative of u, let me just write it down here. So u prime is essentially just using the power rule. So 6 times 2 times x, so that adds up to 12x. So that's u prime. And f prime here is just the derivative of this expression here. But why don't we write this expression like an exponent so we can use the power rule. So this is u to the power of 1/3. So the derivative of this is the exponent times u to the power of 1 minus of the exponent. All right, so let's substitute u prime and f prime back in here. So f prime is 1/3 u to the negative 2/3 times u prime is 12x. Okay, let's simplify this because we don't really want to carry forward the negative exponents. We want to write it as reciprocals. So this is 1/3 u to the 2/3 and 12x. So 12x times this, in other words. So now we're going to use the general power rule to find a derivative of the same function. Generalized power rule implies that if you have a function of x raised to the power of n, the derivative of that is n times u to the n minus 1 times the derivative of u. Okay, so for us to use this formula for our case, we should probably write this as in the exponent form. So I'm going to convert this into, since this is the cubic root of 6x squared plus 1, I'm going to write it as 1/3. Okay, so now I can call this function to be u of x. So now I have u to the power of 1/3. This exactly fits in this form here. So the derivative of y, which is y prime, by this formula turns out to be 1/3 u to the power of 1, subtract 1 from the power here, 1/3 minus 1, times the derivative of u. Okay, what is the derivative of u? Let me just write down here. So the derivative of u, which is u prime, is, well, the derivative of 6x squared plus the derivative of 1, but we did that in the previous part. So it's 12x plus 0 coming out of the power rule. So it's 12x in short. All right, so we're going to carry forward that right here. So this is u prime. Okay. And simplifying this quantity and replacing u with 6x squared plus 1 turns out to be to the power of 2/3. All right, so y prime turns out to be exactly the same that we found in part A, which is 4x divided by 6x squared plus 1 to the power of 2/3. Just one quick recommendation, just don't forget to replace u by the original form. So u is sort of like an auxiliary variable here, and at the end, we should probably replace that with the original x version of that. That's all. Thanks for watching. I'll see you in another video. Bye.